Alright, how about some more tangency problems? At this moment, maybe some students will feel this is rather redundant. If you feel that way, you can always skip. Now for some student who want some further review, here we go. Let's go back to a tangency problem, but this time with some trigonometric functions. How about this one? Y equals sine of x plus cosine of x over tangent of x, evaluated at x equals pi over 4. Again, this is what we are looking for, slope point equation. We are looking for y coordinate, derivative, and slope. Y coordinate and slope, put all those together, we get slope point equation. Alright, let's go ahead and do this. First, y coordinate. This function evaluated at pi over 4. I think I'd better have a little bit bigger font. Alright, and then in place of x, I'm gonna get pi over 4. Again, pi over 4. Also pi over 4. Alright, what is sine of pi over 4? It is square root of 2 over 2. What is cosine of pi over 4? Square root of 2 over 2. Same as sine. How about denominator? Tangent of pi over 4 is 1. So what do we have? We have square root of 2 over 2 plus square root of 2 again. We get square root of 2 overall. Okay, that goes right here. Next, let's find the derivative. We need the derivative of this, and clearly this is going to be a quotient rule. The denominator squared, and then you're going to need u prime v minus u v prime. Let me extend the font again. Okay, this is what we want. Let's see, u prime, that's going to be the derivative, and then v, well, that's nothing more than the denominator. Let's copy it, tangent, and then this is just a numerator, so sine of x plus cosine of x. There you go. How about the derivative? Let's fill out the derivative. The derivative of the numerator, what do you have here? We have cosine of x plus negative of sine, so minus sine of x. That's going to be the derivative of the numerator. How about the derivative of the denominator? Derivative of tangent is secant squared of x, so there you go. Here's the derivative computation. Therefore, the slope is this thing evaluated at the quantity pi over 4. And then this 2 is pi over 4. And then sine of pi over 4 here. Pi over 4. And then that 2 is pi over 4. And one more, and then okay, all right, let's finish this computation. What is cosine of pi over 4? It is square root of 2 over 2. How about sine of pi over 4? The same, actually. And what do you see here? Square root of 2 over 2 minus the same thing. This is 0, so everything will drop out. But let's, for an argument's sake, let's complete this computation. Tan of tangent of pi over 4 is 1, so it goes here. And this is square root of 2 over 2. And plus square root of 2 over 2. And then what is secant? Secant is 1 over cosine. So cosine, this is 2 over square root of 2, or actually just square root of 2. And that thing squared because this is secant squared. Alright, how about tangent of pi over 4? That's 1, so we have 1 squared down here. Okay, I'll be further computation. This whole thing is 0, so I'll just kill it off. I'm subtracting the same thing. Okay, how about the next one here? Square root of 2 over 2 plus square root of 2 over 2. If I add them up, I'm going to get just square root of 2. And square root of 2 squared is going to be 2. And denominator is just 1, so it just goes away. What do you get? Negative 2 square root of 2. Or putting together is negative square root of 8. That is my slope. Finally, let's get our answer. Y equals m x minus x0 plus y0, and this is the slope point equation of the line that we are looking for. If you break up the parentheses and simplify a little bit, you're going to get slope-intercept equation. How about some justification here? Okay, we don't need duplicate solutions, so we don't need this anymore. And how about some graphical justification? Here we go. We have this line. That's a tangent line, but then again, it's a little bit difficult to see what's going on, so here's magnified version. Yeah, do you see this is tangent line? I can clearly see that now. And here is the computation again, with a bit of a color coding as well. The final problem. Again, we can use the same idea. The key computation is the derivative computation using the chain rule. Nonetheless, let's complete the entire problem. Let's begin with y0 to go right over here, which is basically the function value computation at the given point, in this particular case, negative pi over 4. So what is this quantity? Log of 1 plus 2. And what is sine of negative pi over 4? It is negative square root of 2 over 2. And then I have to square it, right? And what is this? Log of 1 plus 2 times 1 over 2. It is log of 3. Excuse me, not log of 3. It is what did I click? I can't get rid of this. Okay. Equal to log of 1 plus 1, which is log of 2. Okay. Sorry about the typo. This is correct. Alright, let's go ahead with the derivative computation. Derivative of a logarithm, so let's use the chain rule. The derivative of log of x is 1 over x. So this is 1 over, and whatever the inside, 1 plus 2 sine squared of x. Now, by chain rule, we have to multiply the derivative of the inside, but if I multiply, the multiplication goes to the numerator. So let's just expand the font here, and then let's do the multiplication up here. Alright, the derivative of 1 is 0, so derivative of this sine squared, how does it go? 2 was there before, and then derivative of sine squared. What's the outer function? Outer function looks like sine, but no, that's not right. Outer function here is power function. And sine of x to the square, the inside function is sine of x, times the derivative of the inside, derivative of sine is cosine. If you simplify them all, this is what you're going to get. 4 sine of x cosine of x over 1 plus 2 sine squared of x, and that is your derivative computation. Next, slope computation. I need a little bit bigger font again. Okay, this is a computation I just did. So let's plug in x equal to negative pi over 4. And then let's do this again. Alright, here. What is sine of negative pi over 4? It is negative square root of 2 over 2. You can always look up that trig diagram. Cosine of negative pi over 4, it is positive square root of 2 over 2, because in the fourth quadrant, cosine is positive. Cosine is an even function. So that takes care of the numerator. How about the denominator? The same thing again. This is your sine value, so this one, and then we have to square it because this is sine squared. Well, what is this quantity? 4 and then this 2 cancel out. Negative of square root of 2 times square root of 2 cancel out. We have the numerator is equal to negative 2. How about the denominator? 1 plus 2 times, and then this is 1 over square root of 2 squared, so this is going to be 1/2. So negative 2 over 2. The slope is negative 1. I think the font is too big. Let me decrease it just a little bit. Yeah, okay. Slope is negative 1, and consequently we get the slope point equation of the line as y equals m, which is negative 1, x minus plus pi over 4, excuse me, plus log of 2. I don't need negative 1, so I just need negative. And that is the slope point equation. I take it back. I prefer to have this negative 1 again so that the slope is negative 1, I can clearly see. If you break up the parentheses and simplify, you're going to get the slope intercept equation, excuse me, but I personally prefer the slope point equation. How is my program here to visualize? Yes, the same deal. Clearly we can see this tangency, and the solution is identical to what we already worked out, the same thing that we did before. So we don't need duplicate solutions here. Let's get them off, and well, here's the solution. How about the solution from the previous problem? Here it is. The one before. Yes, this is tangent line 2. Full solution here. And finally, full solution, this one.